All right, in this video, we're going to take your collection of globular clusters, and I'm going to show you how to plot them as if you were above the Milky Way galaxy looking down. And the reason we're doing this is we can't see most of the Milky Way galaxy because it's obscured by dust, but we can see all of these globular clusters. And so we can use that as a proxy for the Milky Way itself. And by plotting this distribution as if we were above it looking down, we can see where we are in this distribution. If we're at its center, we're at the center of the Milky Way. If we're not at the center of the globular cluster distribution, we're not at the center of the Milky Way. And we can measure how far from the center we are. We can look at this distribution, the top-down projection of this distribution, see how broad it is. That gives us an idea of how broad or how big the Milky Way is. So we can do a lot with this to inform us about our place in the universe and our galaxy's place in the universe. Okay, so I'm going to show you how to do this. Let me share my screen. Okay, so here is the data. This data we copied over from the lab in the previous video. And what we have here are our 30 globular clusters. And for each one, we have a longitude and a latitude, galactic longitude and latitude. So these are angular coordinates telling us in which direction we need to look to see the globular cluster. And then over here in this last column, we have its distance away, which is something we learned how to calculate in the previous video. Now note, I have not entered the absolute magnitude of the Lyrae star. So the distances that I have here are not the correct values. I don't want to give away the correct values. So I'm going to plot these incorrect ones, and then you will repeat this exercise using the correct values. Now, first, let me just kind of show you what this looks like in 3 dimensions. Again, we have 2 angular coordinates and a distance from Earth. So the black disk represents our Milky Way. And in this figure, the sun is plotted out in the outskirts. And so you can imagine a galactic coordinate system, where if we're looking towards the center of the Milky Way, that would be galactic longitude 0, galactic latitude 0. If we go over in one direction in the plane of the galaxy, that's an increasing galactic longitude. We can go all the way around 360 degrees back to looking at the center, or we can stop at any particular angle and look up or down out of the plane of the Milky Way. And that's called galactic latitude. So once you have those 2 angles, you know in which direction to look. So your third coordinate, because this is a 3-dimensional distribution, it requires 3 coordinates. Your third coordinate is then the distance away from Earth. That's how far out you would have to go along that trajectory to find the globular cluster. Now what we want to do is to take these coordinates, these positions, and change them, transform them into a top-down map as if we were above this disk looking down. And then we'll see where the globular clusters land and where the sun lands with respect to them. And we can then confirm or deny this picture of us living out in the outskirts. And also we can use the distribution to figure out how big the Milky Way is. Okay, so for this, we are going to use the graphing tool, and it's linked in the lab, and you've used it before. And we're going to use the scatter option. Make a scatter plot here. And when you come here, you can see we have longitude, we have latitude, and we have distance. So those are the 3 coordinates in your spreadsheet. And we're going to copy this information over. Let's copy the 2 angles first, the longitude and the latitude. And you'll see there's a little technical difficulty that we'll have to overcome. So I highlight them, Control-C. Then I come over here, click on that first box, Control-V, and it pastes them in. But you can see we've run into an issue. Whenever you have a red box, that means something is wrong. It means the graphing tool is not interpreting it as a number. And if you look, it's the ones with the negative signs. And of course, negative numbers are numbers. The problem is we copied these originally from the WebAssign lab. And when WebAssign coded these up, they didn't code them with negative signs, they coded them with dashes. And so we've copied them over to the spreadsheet, now over to the graphing tool. And the graphing tool says, wait, that's not a negative sign, that's a dash, so I don't recognize this as a number. So one thing you can do is go through, and wherever there's a red box, type it back in again using a negative sign instead of a dash. So this is minus 11.25. I can type in minus 11.25. That fixes it. You can do that for all of them. There's another way you can do this. I'm going to highlight one of these dashes and copy it. And then I'm going to come over here and Control F for find. I'm going to be finding that dash, Control V. And I'm going to click on replace. And under replace, I'm going to put a minus sign. So I'm going to replace the dashes with minus signs. Replace all, made 16 replacements. And so now, if I copy these, Control C, come over here, Control V, and it's all good now. They've changed them from dashes to minus signs, and so all the red boxes are clear, and it can plot the points. Almost there, we just have to copy over the distances. That's this last column here. Highlight those 30, Control C, come over here, Control V, and we're done copying the data in. And what it's done is it's taken these three coordinates and it's calculated what are the X and Y positions as if you were above the Milky Way plane looking down. And so you can see the distribution of globular clusters. Again, keep in mind these distances aren't correct. You're going to have to calculate your own distances. And so what you see in this video doesn't represent the correct answer. But it's pretty close. You get the idea. We have a distribution of globular clusters. This is the position of the sun, and it's 0, 0 in this plot. And you can see that at least for the distances that I've inputted, you're going to have to check this yourself. The sun is not at the center of the globular cluster distribution, which would imply that we're not at the center of the Milky Way. We're somewhere in the outskirts. And you can measure how far away by eyeballing where the center of this distribution is. And the human eye is pretty good. It can figure out the center of a distribution of points to about 1 part in 30. So like you'll get it right to the 3% level-ish, just by eyeballing the center somewhere around here. And then just read the coordinates off the plot. You have to interpolate between two different lines, and that will tell you how far we are from the center because we're at 0, 0. And then the other thing that you'll do is measure the size of the distribution. So going from one side to the other, keeping in mind that we have a positive distance on one side, and it crosses over in a negative distance. And so it's a positive number minus a negative number. So you're kind of adding the absolute values of these two. And determining the size of this distribution is a little bit tougher because there are fewer points in the outskirts. And so that's your cause of uncertainty. Anyway, let's wrap this up. We need to label a few things. Maybe for the title, we'll write top down map of the Milky Way. And what we're plotting are globular clusters. That's one way you can do it. And now the coordinates, the X and Y, we don't really have names for them in this top-down coordinate. There's no name. So you can just keep calling them X and Y, but I would definitely put in the units. And these units are kiloparsecs. And then again, you can save it as a PNG. That's the better quality. You can also save it as a JPEG in case the PNG is too big of a file to load into WebAssign. Okay. That's it for this video.